So today we're going to look at the 3 ways to align your parts inside of FlexScan3D. Oftentimes we'll have questions in regards to how difficult it is to align parts inside of our software, because typically inside of other 3D softwares this may be a difficult task or a very time-consuming task to take. So we're going to look at 3 different ways to do that. One, we'll start with the easiest, that is the automated rotary table. This rotary table will rotate. We use the distance that the rotary table moves along with the mesh geometry of our part for our alignment. So once this is finished, we will have a fully aligned 3D model of this part generated inside of FlexScan3D. The other 2 ways, which I'm going to go over after this is finished, is the manual alignment. This is if you do not have a rotary table, but because we do geometry-based alignment, we simply place the part on a manual rotary table or a Lazy Susan, rotating it anywhere from 20 to 30 degrees, and the mesh geometry aligns to the previous scan. As long as there is enough overlap for the software to understand that these are familiar features or dimensions on the part, it will align automatically. And lastly, there is the photogrammetry dot alignment. Now, contrary to most 3D scanners or 3D software, we do not have to place dots or tracking markers on our part. As you see here, this is just a wooden part that's not been treated with anything. But the photogrammetry dots we place on the rotary table itself, or the Lazy Susan itself. Oftentimes this is needed for really symmetrical parts where there's not a lot of geometry to align to. So we use the dot recognition feature in FlexScan to align the tracking dots, which in turn will align our mesh. So this has finished scanning, and you'll see the full 3D model generate on the screen. And this is a standard manual rotary table, nothing special about it. See, here is our fully aligned part. For that process, there is no alignment, no data manipulation. I even had it set up to where I was not picking up any data on the table. You can set cut planes to only generate a mesh from what you're interested in picking up. So now we'll go into the manual alignment. I will just place my part down on the rotary stage, and we'll move this away. I'll press scan. We have our first position, and I will rotate, scan again, and again I'm not using any automated feature. This is a manual rotary table that I'm simply just moving, and you see that we are aligning automatically. Each time I hit scan, a point cloud is generated, and then our part is aligned based on the geometry. For this feature to be used, you do not have to have a rotary stage. You can actually move the part around on a table, or better yet, if the part is large or cannot be moved, you can simply move the scanner around the part, and the same process will apply. Lastly, we'll cover the photogrammetry alignment feature. This will be needed or can be used in all situations, but if we have parts that are symmetrical or there's not a whole lot of geometry to align to, what we do is we use these photogrammetry dots. Right now I have them placed on this manual rotary table, but you can place them on almost any surface, either the automated rotary table, an actual table, whatever you need to do to get information on the parts that you need. So I have a part here that does not have a whole lot of geometry. It is simply a box So this part here, we will just press scan. And the green dots that you'll see that populate up on the screen are the recognition of the software that these tracking dots are on the table. So as long as we are able to pick up a portion of these dots, we can rotate our part, press scan again. It will pick up those tracking markers and align automatically. And one more time. With the tracking dots, you can move the rotary table up to 90 degrees at a time because we're not relying on the geometry of the part, we're relying on the table. So as you saw before, where I was only able to move anywhere from 20 to 30 degrees, with the photogrammetry feature, you can move a much further distance and still automatically align your part. So you see I moved a greater distance. And we'll just do one more. Okay, so we have gotten all four sides of our part based on the photogrammetry feature. Lastly, I'll cover the manual alignment feature. This is not one of the three automated alignment features that we walked through before. This workflow would need to happen if you move the part too far. Let's say you scan it here and then there. Well, it's not going to automatically align when you move the part that far. So if an alignment didn't happen correctly and you need to do it manually, I will show you how simple it is to make that happen. So I'm going to scan it in two positions. Okay, and it's still automatically aligned, but I'm going to separate them to show you the workflow. Okay, so I have two scans here. The red is the most recent, the silver is the one that I had done previously. So all that you need to do is move the part relatively close. Does not have to be exact. I'm still a little bit off. But you move the part relatively close, you select both of the scans that you want to align, you press the align button, and it will snap them together, and now we have an aligned point cloud. So, hope that was helpful. Thanks for watching, and please feel free to visit our website if you have any further questions.